Sound test. 1, 2, 3, 4. Sound test 1, 2, 3, 4. We will start in a few minutes, as always. Hi, Walrus. All right. Here we are live. Live. Seems all is good. That's great. And look at what I can do. This thing. Around a week ago I experimented a little bit and I managed to find a way to highlight messages, which should be very convenient. Because I sometimes reply to a particular message that is usually about a problem that I'm solving. Hi Rakesh. I also changed the chat settings so that the display above my face would be only for 15 seconds. I think that's already enough. And if I want to reply to something, I will just highlight it. Which, by the way, was not simple. Hi. What do I think is the rating of problems E and F? I have no idea. I don't know the problems yet. I'm going to solve them one by one. So in the past week I did the Huawei IOI camp. Then I also spent some time changing the settings in OBS for the stream, stuff like that. For example, now my camera will not hide such a big area. So there is background removed. Hi, God Gamer. Welcome back to the stream. Stuck in problem C. Well, looking at the number of accepteds, I would say most people should be interested in the solution for problem D, because there is a huge drop of number of accepteds. And then E. I like the comment, good evening, and in brackets, Indian Standard Time. Good evening to you. This is how people should greet each other in the internet. Good morning to you, and in brackets you provide your time zone. Okay. I don't think I will manage to solve all problems, especially look at how many people solve this. No, I don't think I want to talk about the climate change crisis. Okay, so this is linked to the contest. We will start from this thing. Oops, that was my mistake. Just a question. Both on Twitch and on YouTube, you now should see in the chat this message with my link, right? Let me know if you don't see it, so you cannot click it. I'm using a different setup today, hence the question. Okay, difficult contest. Contest is a string S with uppercase letters that denote problems. Contest is difficult if it contains FFT or entity as substring. I don't think many Division 2 participants know that. Task is rearrange the problems. The problem. Well, that's unusual. That's a very simple typo. Rearrange the problems in contest S in such a way that this contest is not difficult. You want to get rid of FFT and you want to get rid of entity. So what about we put T before F and T before N? Oh yeah, just put all the T's at the beginning. Then you don't have a way to get either of those as a substring. And there are test cases. Test case. I will build a new string, call it out. For every character in S, if it's equal to the T value, then I don't know, increase the counter, else put it to the new string. So the new string will contain anything other than the T characters. And at the end, I want to output that many characters T and then the out string. There is a counter starting at 0, and this is how many T's there are. It puts T's at the front. CSES problems. One day, yes, for sure. Actually, I asked the author of CSES problems whether I have his permission to do stuff like this, so, or he doesn't want people to generally do full editorials of full categories. I'm waiting for his response. Will the stream end before the contest? Yes, I will stream until few minutes before the contest. In particular, I won't do much, I couldn't even do much submitting after the contest starts because I will not have the priority of judging. During the Codeforces contest, it's hard to use Codeforces outside of the contest. I need to remember to when I highlight a message like this, I need to remember to unhighlight it. By the way, do you see this green tint under the message? Like, it's not entirely white, right? There is blue background for the whoever sent the message, and then there is this white greenish background for the message itself. It is because of the, let's say, green screen behind the message. The setup looks like this, where there is green screen that I need so that I could only capture some part. Accepted. I think I spent more time waiting for the verdict than actually coding it. Second task, left and down. Project Euler. I think that, first of all, I believe that Project Euler idea is that there aren't many editorials online and you are supposed to try to solve a problem on your own. Second thing is that I'm not that good at math. I would struggle heavily with difficult tasks, and I think it's not very fun to watch because I might even lack knowledge to solve something. For algo problems, I will always have some ideas. I can even explain why I think something is difficult. I'm an expert at algorithms. I'm not that good at math. Better than average, but not that good. Out and not ans, whatever. Not a big difference. I thought that this is the output string compared to the input string. This was opposed to the string s. There's robot located at AB on infinite grid. We want it to move to 0, 0. We have integer k. Choose two integers, move by that much to the left and down. The cost is 1 if you use some operation first time. So once you use a pair like -5, -4, you can keep using it forever. Bring it down to cell 0, 0. So we want to preferably use some operation and then keep using the same operation. Then the most basic operation that allows us to do almost everything is to move by 0, -1, or to move by -1, 0. Those are two unit operations such that I can, with just those two, I can move anywhere I want. I will pay 1 for the first time I use something. So this always cost of 2 is possible. But maybe cost of 1 is enough. Cost of 1 is enough if one type of operation is enough. For example, if the target is at, let's say, 8, 10, I can make my only move to be 4, 5, and I can just keep repeating it until I get there. The question is, can I have a move that fits within the bound k? And for that, I'm going to use greatest common divisor. I will look at the target. In this case, target GCD is 2. 8 and 2, they have common divisor of 2. If I divide by 2, I have this smallest possible move that I can perform, so that I would get to the target by just doing this move. Then the question is whether it fits in k. Also, k is long, long. So what we are doing is ABK, compute GCD, divide both. If now this fits, so I can make such a move, then the answer is 1. Else it's 2. The 2 represents applying operations like that, which should always be legal. One, two, 1, 2, correct. Have I considered high-frequency trading firm? I don't think all red coders are joining Jane Street. Maybe you know a few and just they know each other as well and they all happen to join Jane Street. Jane Street doesn't have an office in Warsaw and I don't want to move abroad. I did consider high-frequency trading. I even had an internship in one company several years ago and I had a follow-up offer. How is it called? When you continue with a full-time job. If not for teaching algorithms, maybe I would do that. But that being said, I like teaching algorithms. I like competitive programming. So if possible, I would want to continue here. Though, yeah, I don't earn close to the amount I would get in HFT, and I'm sure that I could get a job. Count good numbers. Task C. Also in my setup here, the difference is that I don't see the number of viewers. Can I fix that easily? Can OBS show me that? I don't think so. What other option do I have? Chat. Oh, this will work. Test. In OBS I can also open the chat from Restream and it shows me the number of viewers. Okay, fine. Prime number is defined like this. Prime factorization is splitting into primes. We call number good if all primes consist of at least 2 digits. So number is good if it's not divisible by 2, 3, 5, 7. Calculate the number of good integers from L to R. Okay. So in range, the task is in range LR, count numbers not divisible by 2, 3, 5, 7. Obviously, when you have a question about such a range, you should focus on counting such numbers in range from 1 to R, minus subtract those in range from 1 to L minus 1. So now we focus on this. We focus on, given some upper bound, count the number of numbers not divisible by this in such a range. I see 2 solutions. One is inclusion-exclusion. Another is that when you look at those numbers and you look at their product, or least common multiple, but let's say the product, this is 210, I think. If this is 210, then once every 210 numbers, everything repeats itself. So whatever the good numbers are among the first 210, the next 210 have the same pattern, because they have the same divisibilities by all of those. So I will use this solution instead of inclusion-exclusion, which is also fine, and you should know how to do it both ways. Maybe even I will do it both ways, but I will now focus on the function count up to, given n. So up to n, count values not divisible by 2, 3, 5, 7. And I will do this. If n is, for example, 300, I know that the last 210 numbers have the same pattern as everything else, so I will instead work with this, because I know the consecutive 210 values, they always have the same count of how many of them are not divisible. So what about this? Answer equals fixed value already computed in advance multiplied by n over 210. So whatever the full amount of 210s I have, I multiplied by the count of it that I will count separately. And also for every I up to n modulo 210, like here up to 90, smaller or smaller equal. Yeah, that's a small inconvenience. For this, if or maybe I will make a brute force as well. Here is count is 0 for everything from A to B. If I modulo 2 is non-zero, and I modulo 3, and I modulo 5, and I modulo 7, and plus plus. So this uses a brute force to compute for a range. The value fixed, I can even compute it here, whatever. Maybe with static. Fixed is brute force in range from 0 to 209, let's say. So in every consecutive 210 values, it should be the same. I see that in the chat you're telling me how many are there, and I could actually also compute that using inclusion-exclusion. That being said, I'm lazy, let's say. I already I anyway need some code that will finish with the last few values, so as well I can use it. Answer is this, and then answer plus equal the brute force in some range. And that is usually from 0 to n modulo 210. We just need to figure out plus minus 1. Return answer. Inside of the test case, what you read is low and high. and we need to output count up to of high minus count up to of low. Finally, what about this modulo exactly? Well, I need to count n as well. But if n is 210, then this takes care of everything. Well, I can say that this takes care of numbers from 0 to 209. And then this only counts 0 up to 0, which isn't counted, so it doesn't matter. I think this will work, though it's not obvious. I'm not particularly proud of this code. 21 to 27 something 70. This is incorrect. This is incorrect. How is this? I see some suggestions about prefix sums. Oh, low -1, yes, obviously. Thank you. I'm not going to speed this up because it's not needed. There are 1,000 test cases. If in each of them I do extra 210 operations, that's fine. In competitive programming, you're not supposed to necessarily try to get the fastest possible code. You want to get the easiest possible code that is good enough. Accepted. How do I get the input in the file so fast? Well, let's see what I click. Copy. I click on Genie. I have a keyboard shortcut to go to terminal. I type output to the file, enter, Ctrl-Shift-V, so paste, Ctrl-C to close. And now it is in this file. I created a file. Of course, alternatively, I could open the file and I could copy from here, paste there. But it's easier to do it in the terminal. Let me see if the tutorial mentions the inclusion exclusion. It does. Yes, so this is second solution. You can read it there. I will move on. Next will be D. Before I do it, let me show you what I'm organizing next month. I haven't published yet, but you can make a screenshot if you want. Let me see. So if you want to read this, you can take a screenshot. I will do weekly classes. The price is around €100 per month if you want to join live, and €50 per month if you want only access to recordings, the problems, but you don't want to join live. It will be similar time to the stream today. So like right now in 5 minutes it would start on weekdays. I'm thinking Mondays, Tuesdays, but that's not decided yet. And this thing will start like in 1 week plus 1 day, something like this. If you're interested, just maybe tomorrow I will put the blog on Codeforces where you can when you can register and pay. So far this will be the cheapest thing I do in terms of teaching where you pay. My live streams are still free, but usually my one-on-one classes or groups were more expensive. We'll see how this goes. I just hope I'm not overwhelmed by the amount of organizational stuff, like, handle all the payments. We'll see. I hope many people will register still. And maybe this is a success and I will continue it for the next year or multiple years. We'll see. So take a screenshot if you want, and I'm moving on. For ICPC, I mean, if you feel like it's too long for you to rewrite, then that's an issue. That being said, how much time does it take you? If it takes you up to 15 minutes, I think it's fine. The, of course, perfect answer is that you should have something short that you still understand. But yeah, it's hard to answer your question. What should you prioritize? Short code that you don't understand, or long code that you understand and can modify if needed? Yes, University of Warsaw prepares for CP contests. Every Thursday we have a 5-hour training contest using some old ICPC contest and the analysis session. I'm one of the coaches in Warsaw. Ivan Chance Otis. Ivan Chance Otis. First, Ivan Chen. Do I know him in any way? (2014). That's a nice result. Isn't it unusual to see somebody with a gold medal in IMO and only one participation? Okay. Is this the website for the thing? I will check it out later. Let me write it down so I wouldn't forget. Okay, problem D. Okay, I can answer that first. So regarding this task, here's the thing. When you investigate divisibility by 3, let's say, what you have a pattern that says divisible, no, no, divisible, no, no, divisible, no, no, right? You have this. Maybe I will write it as 1 and 0. And so on. This is divisibility by 3. If you have divisibility by 4, it will repeat once every 4 elements. Like so. Now, if you compare those two, divisibility by 3 and 4, the first number 0 is divisible by both, and then number 12 is also divisible by both. Right? 0 and 12 have the same divisibility by 3 and 4. They are both divisible. And afterwards, everything is the same. Just like 0 is the same as 12, 1 is the same as 13, 2 is the same as 14, and so on. Those two numbers have the same property of divisibility by 3 and 4. You can add more numbers here, and the same thing remains. There is a cycle of size product of those values. More general, least common multiple, LCM. Now, the first difficult task. Linear strip divided into m cells. You're given n segments, 4 numbers. Cover cells in range and exists with this probability. Your task is to calculate the probability that each cell is covered by exactly one segment. Before this, I was almost sure it will be some kind of DP. Now I'm not sure. So we have ranges. I'm thinking that this will be a graph problem, though still solvable with DP. We have a sequence and info about some ranges, like this, this, and so on. And we want to collect ranges that will add up to the sum of everything. First, let's say how we would even check if that's possible. If there is a range from 0 to 5, we can mark the position 5 or position 6 as available, that if something starts there, it can be used as continuation. Then we continue and so on. We are talking about probability, so we maybe will multiply probability. I'm thinking dp of I, probability that we cover prefix up to I. And there is this issue that this is easy to do transitions if we only care about the ranges that we should use. But also I need to say that all the remaining edges, ranges should not be used. But I can then maybe at the end handle that. No, I think I need to do it as I go. So as I say that this is the range to use, all the other ranges that I'm not seeing here, I should multiply by the probability that those are not happening. Let's say as I process this, I will say all the ranges that have their, say, endpoints anywhere here, I want to have the product of their stuff. For that I will use prefix product, and I need to be able to divide. So if there is range ij, then I will do transition dp of j plus 1 plus equal dp of I multiplied by probability of this range multiplied by probability that other ranges that have endpoints here do not happen. Probability not of endpoints in this range, except for this range that I'm using right now. For example, if the probability of this guy is, say, 0.7, but there is also another range here that has probability of, let's say, 0.4, when transitioning from here to there, I will multiply the probability by 0.7 for this range happening, and 0.6 for this range not happening. And I think that's the way to do it. It should be also possible to do this problem without the modular inverse if you use segmentary. But I'm going to use something simpler, I think, which is prefix product. Let's read the input. There is L, R, and the probability. Oh, there is probability P over Q, so we need to use modular inverse. I guess there's no way to avoid it. And in this task, if you don't know modular inverse, you need to just ignore that part of the statement. Just think that there is no modulo and you're using real values. Kazakhstan championship. I mean, there are many contests happening. I think I will prioritize Codeforces where thousands of people try it. I don't doubt that you also have some interesting problems, but it's a niche contest. I'm from Poland, so from time to time during streams I might cover Polish Olympiad problems. I even have this idea that maybe I should, during streams, cover the past problems from the first stage of Polish Olympiad, so the home stage. Okay, modular inverse. This is boring stuff. Mostly you should just copy paste it during contests. Will you solve IOI problems that will be available soon? Maybe. I think I will do live commentary. Maybe I will think about problems if the statements are available, but I will not code it live, I think. because then I need to really focus on it, and I prefer just want to talk. Maybe I will invite some guests. We'll see. Okay, I have the modular inverse stuff. So here the probability is the division between P and Q. This is the actual probability of the range. The range goes from L to R, and I will say this. Starting at L, there is a range that ends at R and has this probability. M cells. I will rename M as the uppercase L for the length. Maybe let's call this len. And this will be n count. It's just too easy to mistake those two variables. We have this vector of per int double, not double int. This is starting of size len plus 1. What do you want? Division is it a keyword? Ambiguous, yeah. So my division. Okay, I need to also have the prefix product. I want product of all the stuff that ends up to somewhere. So prefix product of R multiply by P, not by 1 minus P. This is 1 minus P because I want probability for something not happening. This is prefix product of things that don't happen. Then I need, by default values 1 are there, and I need to propagate it like always in prefix sum. Product of I is multiplication with the previous element. Okay, now for the transitions. Well, we have dp. By default we are starting from position 1. The answer will be position length plus 1. And for every I, for every range that starts there, how do I do it? Tie, untie, auto? I don't remember. So for every endpoint and the probability among starting of I. Does this compile? I'm trying to use modern C++. Set but not used. Okay. So we have range I to j, and it happens with probability p. The transition is dp of j plus 1. I need to add by something. dp of j plus 1 plus tmp modulo mod. Now that this transition is dp of I, we need to multiply with the probability of this range, and we need to multiply this with probability that other stuff here are not happening, and that's the division of prefix product up to j minus, or divide prefix product up to j, sorry, I minus 1. This will be product of the range from I to j. Additionally, you need to divide it by the probability that this range is not happening. Because in the range from I to j, you would want to say everything else except for me is not happening. So you divide by both. I will at the end summarize all the formulas. So we have P and you have no. There's like... Co chcesz? Gdzie? Gdzie? Now there's like 20% chance that this works first time. Yeah. Something has too small of a size. Line 40. Starting of L. No test cases. Okay, I'm trying to read the number of test cases. Okay, that was relatively small mistake compared to everything else that could go wrong. But you see, there are a lot of small things that can go wrong, and this is why that 20% estimate still was very reasonable. Watching you live feels so slow. I usually watch you at 1.5. It makes a lot of sense. I also watch stuff on YouTube, usually with increased speed. And live, you cannot really do that. You know, what you can do is you can pause the stream and then watch a little bit. That's the beauty of live streams. I mean, there is my general advice on how to practice. You will find it on Twitch. If you type !practice, you will get the link. How did you figure out the line where it fails so quickly? I mean, with proper flags, C++ will show you where it fails. So what I did was, it was important how I compile it. First of all, so there is this, I will copy. This is my compilation command. I think here -g and the -d glib cxx are important stuff. Then what I did is I ran the program called the GDB using my program A. And then I ran on this input. I don't need that. It will also check some extra stuff like the memory leaks. Then let me hide. And then BT for backtracking. Yeah, I messed something up. This run on this input. Oh yeah, because sorry, now the program doesn't fail. But normally it will show me a lot of information about what happened. It's just some tool. The Jagiellonian University, AlgoPrep there is high quality. I think it's very high quality. I think that it's hard for me to compare it to Warsaw because I didn't attend Jagiellonian. But yeah, they have achievements. So there is nothing wrong with the Jagiellonian University. DP of 0, probability of 0 range selected, and then the DP. Parag, I don't fully understand what you're suggesting, but sure. Okay, solution summary maybe. Kind of using examples. There is this sequence that this is task D. There is this sequence that I want to cover, and every probability has some probability of, every range has some probability of happening, let's say 0.7. Maybe this has a probability 0.9, and there are some other ranges, like this one 0.2 and this one 0.2. I always start here, and I want to investigate, I want to find the probability of covering everything without intersections. In this case, the only probability for that is that those two ranges happen. I do DP transitions. Whenever I see a range, I just do a transition. So if I start here with probability 1.0, I will transition there, and I'm here with this probability 0.7. Now, I cannot simply transition from here to there with probability 0.9. So I cannot here just say 0.63 and be done, because I need to additionally guarantee that those things are not happening. So the probability of this transition from here to there, that's 0.9 multiplied by nope in my code, and that's product of probabilities of other things in between not happening. That is, this thing has probability 0.8 of not happening, this thing has probability 0.8 of not happening, and in this range I want probability of all the red values, the product of values 1 minus p. I use prefix product for that. If I know the prefix product up to the end, I divide it by prefix product up to here, then I will get the product of this range. In order to divide, I need modular inverse. So I need to divide modulo. Additionally, I need the product of everything up to the end, including possibly some ranges that end here. They are just not the range that I'm using already. So I will include all the stuff that ends exactly here, but I don't want to include this. I don't care that the probability of this not happening is 0.1. I don't care. I want to exclude it. So this product of a range I divide by 0.1 because it's unnecessarily used. I'm not interested in it. I want the product of red values for the other ranges inside of this range. So this is the transition. I say dp of j plus equal dp of I times this, where nope comes from the prefix product. Instead, what you could use is, for example, segmentary, that could also give you product of a range. Maybe there are some tricks not to include this single element. For example, if the task said that at every position there is at most one range ending there, then it would be easier to code this. Because I would take product range up to position j minus 1 and I wouldn't need to divide. Excluding future segments is wrong. Yeah, Pollux, you're right. We don't want to exclude other things because we can still use them. I want to make sure that every range that I'm not using should be, I should count its probability of not happening only once. So best way to do it is when you see it as you go from left to right, when you encounter it but you're not using. Parag, now I see what you're saying. Actually, I had this idea in my head, but I thought that it's incorrect. I thought that maybe we should focus on multiplying stuff that we're using. But then the issue I saw is that we have the sum of a lot of things. Let me see. If I, for example, here have 0.63, the product of those two values, I guess I can also multiply it by 0.3 to say that I'm kind of canceling it. Can I do this? So I do transitions by just multiplying this. At the end, this value I divide by the product of all nopes. That seems correct, because this will be divided. No, wait, divide is stupid. Wait. I want to at the end multiply. So I think I need to transition with this, divide by 0.3. At the end, if I multiply by all the nopes, 0.8, 0.3, 0.1, those values will cancel. I think that should work. And I had this thought, I decided it's not correct. So that was that was bad. Let's see. So now my theory is we don't actually need this, the prefix product. When doing the transition, I also don't need nope. I will just multiply by p, divided, I have a déjà vu, divided by, sorry, p divided by the 1 minus p. Okay, at the end I multiply this with the product of all nopes. Does it work? I got some negative values. How can it be? Oh, yeah, more. Okay, I think it's correct. So I overcomplicated. I mean, mod plus is needed because 1 minus p itself would be a negative value. So when you subtract modulo, you usually need to add something to make it positive. Okay, so that's a better solution. And I'm guessing the editorial should describe that. Well, they have prefix sums, products. Here they don't. Yeah, they start with the product of all the nope values. So this is the second solution in the editorial is my also second solution. By the way, this it looks scary, I think. Have I solved the Manhattan pair question? Manhattan pair question. I remember one Manhattan pair question from one of the past few contests. Oh yeah, it was from the Division 1 contest recently, but I did not make a stream on it. Do you mean that contest? Yeah, let's go E indeed. Okay, last problem for today. Set of integers, complementary sums. If you can do this, choose an array, calculate the sum S of everything, S minus the value, add to the set. Values in the array can be repeated. Count distinct sets of complementary sums with values up to x. Okay. So not Aditya. I solved that problem because I was a tester. I have not discussed it during a stream. Maybe one of the next few days I will do it. I will go through the problems, all the problems except for the last one. Okay, what can we do here? So there is this A1, A2, A3, A4. They have the sum. Then I'm considering the set of values, sum minus A1, sum minus A2, sum minus A3, sum minus A4. If I add all of those, so sum of set values is equal 4 times sum, so n times sum, minus a sum, because if you subtract A1, A2, A3, A4, you have this, so that's equal to that. Well, unless repetitions. The task said that in set we remove repetitions. For example, this array of size 4 gives you only those 3 values. If not for repetitions, let's see. Is this set valid? I will just do something random. 20, 23, 30. What array A would give me that set, assuming that n is equal to 3? So I guess I can sum this up. The sum of the set is 50 plus 23, so 73. That's not divisible by n minus 1, so let's modify to this. 74. Sum of set values is equal to that, so apparently sum of A is equal to 37, and then this is 37 minus 7, this is 37 minus 13, this is 37 minus 17. The sum of those is 37 indeed. Now, so 37 minus 7 is 30, minus 13 is this, minus 17 is... Okay, so from the set, I could get the array, because the sum of values was divisible by n minus 1. But it's also possible that the set hides repetitions. For example, if this was the case, it seemed that there is no solution. But maybe this actually hides a set that looks like this. And then I care if the sum of all of those is divisible by 3. If not, maybe this sum is divisible by 4. Maybe this is divisible by 5. Maybe this is divisible by 6, and so on. It seems like almost every possible starting sequence, if we expand it like that, eventually it will be divisible by n minus 1. Unless maybe those values are very special. If the set of values is simply a value 1, wait, can it be one value? Can n be equal to 1? If A is a single element, then the set will contain a 0. Can we have zeros? Okay, if the A array is 1, 1, then sum is 2, minus every element is 1, so you will get this. If A is 2, 2, then the sum is 4 minus every element it's 2, and so on. So that resolves this situation. For the second test, you have this. So for some reason, here everything is possible. Here also everything is possible. And here I'm guessing it's not the case. This is just 7 choose 1, this is just 5 choose 2, and is this 10 choose 3? That's 5 times 3 times 8, so 120? No, that's too much. 120. So among 120 possible triples of values, only 34 of them are good. Zero is not allowed by this. Oh, I see that condition. Yeah, this says that we cannot have 0 in the set. Sure. Okay, say that the set of values is 1, 2, 3. Okay, what if the set of values is like 2, 4, 6? Maybe that will be difficult for some reason. We want this to be divisible, the sum divisible by 2, so that's easy. What is instead? Okay, up to this n equal to 2, everything is divisible by n minus 1, so it's easy. Here it might be not divisible by that, but when I have this 2, 4, 7, the sum is not divisible by 2, but if I add another something, the sum will sometimes get divisible by 3. In particular 6 plus this, that's not divisible. But then maybe this is divisible by 5, sorry, by 4. No, it's not, but I can add something else. And now it's divisible by 4, right? 10 plus 14, 24, yes. So sum is 24. So the A could be 17, 17, 20, 20, and 22. How could those values be so big? Something's wrong. Oh no, the sum I need to now divide by n minus 1. So the sum is 24 over n minus 1, so to 6. Oh, I see, and now things become negative. So the A would need to be elements negative 2, negative 1, negative 1, negative 2, sorry, 2, 2, 4. For those things, we have the sum equal to 6, and 6 minus those elements will give you that. Okay. So what's the issue here? After multiplying, you want the sum divided by n minus 1 to be greater than max element. Or in other words, sum needs to be greater than max times n minus 1. That seems to be a very strict condition. Sum greater than that. Is it true right now? The sum is 13. Is it greater than 7 times 2? No. So if I try to already do something with that, sum here is equal to 13 over 2, that's 6.5. Then indeed I would have the A array with negative value. So that's minus half, 2.5, 4.5. The sum should indeed be this. It doesn't work. I'm not participating in the division round today. What I'm going to do just after this stream is I'm going to watch volleyball, because today there are finals of VNL, the final four in volleyball women edition. And in a few weeks there should be also finals for men. Poland plays against Japan, and then Brazil with Italy. Maybe this condition is very important and it's enough. By the way, when I get to problems of this difficulty, at this point it starts affecting my performance, the fact that it's during a stream. Because here, without a stream and without explanations, I could faster go through some examples, experiment. Breaking quant, what does it even mean? Okay, this thing means that the sum isn't too far away from it. So the maximum versus other numbers, there is a small difference. When I repeat the maximum, nothing much changes. But is it true that eventually we'll have this? What about that? I know here the answer for 310. I can implement this check and see what happens. So what if we... Maybe just this condition is enough. I have no idea. Iterate triples of elements. K is the maximum, and I want to check that sum, where is it? Sum greater than this. The sum greater than n minus 1, so 2 times max. Most likely this is not enough, because it's just a condition that needs to be satisfied, but maybe there are more. No input. 50. By any chance, if I make this into a stronger condition, will it fit? Oh, 34. Can I check this here? No, I cannot. Huh. So is the condition that sum needs to be greater than n minus 1 times max? And now I here added plus 1, but I'm guessing that maybe this is slightly different, like it's actually n-1 or something like that. But this happens to work here. What does it, what this thing becomes when n is 2? Sum greater than max plus 1. I don't think it's true. So maybe this is something like n minus 2. The upper bound x. But the elements from the set need to be up to x. The elements a can be anything. My theory right now, GodGamer, my theory is that I need to count values up to x such that this will be satisfied. And I think we will aim at time complexity 200,000 times logarithm. But for now it's difficult for me to explain why. But I have something in my mind. Like it will be primes if like time complexity, whether we iterate multiples of something. Yeah, what about duplicates? I have a theory. So in Q, in the sets that we are investigating, there are no duplicates. And with some experimentation, I saw that for this, or maybe that, if when we make duplicates, either this condition will not change or it will get worse. If I keep repeating the biggest value, this condition stays the same, so it remains true or remains false. So maybe just by repeating the biggest value we can always make the proper divisibility. If so, we just want values to be non-negative. Actually, the values should be greater or equal 1, right? A values consisting of positive integers. Okay, let's think about that. Sum of the set values is equal to this. So the sum of a values is equal to sum of set values divided by n minus 1. And I want every value in a to be at least 1. In particular, the maximum. The maximum is this. Sorry, the minimum. So this thing, which is sum of a, let's see. This is equal one of the elements. Sum a minus a4 is equal one of the elements in the set. So element a4 is equal sum of a minus set 4. For this being the maximum, this is the most dangerous. So then sum a minus maximum inside of the set, that still needs to be at least 1. If I now plug this here, I get this. So sum set is greater or equal than max times n minus 1 plus n minus 1. I have this. Does it match what I tracked here? This greater equal the maximum times this plus n minus 1, which is 2. I think it's okay. Yeah. Let's run. Okay, still works. All right. Then I'm going to assume that this is correct. So it's enough for me that I create such a set that what gets calculated as the smallest element in A is at least value 1. That's the lower bound. It's absolutely not trivial and not obvious why this is enough and why other elements will not get messed up, why by repeating the maximum in the set I eventually get divisibility so that those numbers would be integers. I don't care. I just sometimes in a contest you want to assume that the problem is solvable and that your ideas after some time are good enough. Maybe nothing else is needed. This is that point for me. Okay, now it's not a random inequality. This in some way represents how far we are. Let me maybe think about an example. If we have few elements and the maximum among them is 10, we want here the sum of maybe 100. We want here the sum of values to be greater or equal than 100 times 4 plus n minus 1, so plus 4. So the sum needs to be at least 404. In other words, all of this needs to be a sequence of 100s with at most 96 units lost. So we can think that this is by default 100, 100, 100, 100, 100. Decrease the elements by at most 96 in total. And this still needs to be a set, right? So yeah, the sequence needs to be increasing. I also see a solution with possible squared in time complexity. Now here comes a trick. If you can decrease by at most this in total, this element cannot be value 70, because if you want this to be increasing, then those previous elements also are smaller than 70, and you already lost too much in total. Actually, let's think about the reverse problem. I'm making a sequence of, by default, n zeros, make an increasing sequence with ties, with sum smaller or equal 96, assuming that 100 was the maximum. Also, would we iterate the maximum? This will be a sequence of how much we are missing up to the maximum. For example, this sequence, it means that there is one element equal to the maximum, one element equal to max minus 3, max minus 3, max minus 5, max minus 6. So the sum is smaller than the maximum times n by something, and it cannot exceed, in our example, 96. Okay. Now, no, squared, forget about that. But there is this property that if you have increasing sequence, if some element is 5, then all elements after that need to be 5 at most as well. Because of that, every element at index I, you can limit it by this maximum that you want to get, so 200,000, divided by the index, counting from the end. Because if there are 7 elements until the end, you cannot exceed max over 7, because there are 7 elements that are at least you. So maybe using a simple example. If there are 5 values, it's increasing, and the sum cannot exceed 100, then the value here, it cannot be 30, because there would be 30 plus here, 30 plus here, 30 plus here, and the sum exceeded 100. The value here is smaller or equal than 100 divided by 4. Here, smaller or equal 100 divided by 5. Smaller or equal 100 divided by 3, and so on. And the sum of those counts is n log n. Sum of possibilities is equal n log n, which will appear, I think, in our time complexity. And we will have a dp. For every position, dp is What is number of ways so far for this element? Or maybe instead we'll think, if I put an extra +3 here, actually it gets multiplied by the suffix. So I actually have +12. So it seems we have and the length is there. That's tricky. What do we count? Number of ways. This starts as 1. Then for every position, or for every suffix that is possible, we consider what value to put here, or by how much to increase this position with this remaining suffix, so everything gets multiplied. For now, let me do quadratic dp. I'm making new dp. Actually, that's not needed, right? Yes, this stream is supposed to end before the contest, but I don't have enough time to code this, and I don't even have a full solution yet. Also, let's see. So this was solvable in 20 minutes, 14 minutes. I see tourists struggled with the last problem. What was the last problem about? Some kind of string task. Okay, among n positions, for each of them you choose by how much to increase. Oh, right, there cannot be ties. You're right, yeah. Thanks, Sars. I forgot that we're investigating the set of elements. Right, so this doesn't make sense. Okay, so maybe back to the square root thing. Actually, I'm starting to think that n can only be up to square root, because the sum of distinct values something something, it will never satisfy this condition. Yeah, I think I'm quite confident about that. So n is up to square root. Two seconds. I'm thinking if it's enough here to just in proper order do transitions that look like this. Just do it increasingly, I guess. So if there is suffix of size 5, you can increase it by 5. But no, we then don't have any information about increasing. Yes, we do. And we need to increase by at least 1 unit. If you see, let's say, suffix of 5 elements, you need to do at least +5 here and, sorry, +1 here. and that increases the sum for everything. I'm very close to a solution, but I cannot do it in 5 minutes. That's a pity. Okay, I will open the tutorial, but only because the contest is upcoming. Also, please register for it if you want to. Such a long tutorial. Something, okay. I think this is what I've just done. Yes. Prefix sum, I don't know why we use that, and square root of x. Okay, so that's basically my solution. You just need to spend some extra time thinking about the details. Okay. Well, that's a hard problem, much harder than the previous one. Okay, I will not code anymore. I will, for the last 4 minutes of the stream, summarize what I know about the solution. With this condition, and you should register for the Codeforces round, we have this condition, right? This. Given nx, count sequences of n distinct elements that sum is greater or equal max times n minus 1 times plus n minus 1. Okay, this and all the elements are up to x. X is the upper limit. Okay. When you have maximum in your sequence, then your sum is obviously limited by this. If maximum appears n times, then you have this. And this condition, it means that you need to drop only a little bit below the sum. For example, assume that maximum is 100 and is 5. Then you have a condition here that sum is at least 404, which means that among your 5 elements, it's increasing, every element is at most 100. You cannot even have a value 1 here, because that's already dropping too much from the value 100. You want this element to be equal to the maximum, and the other elements should be nearby. You cannot have a big drop. Let's say this should be okay. The sum is big, because how far you differ from the maximum is small. Let's say by default I will say the elements are 199, 98, 97, 96. This is the biggest possible sum. Already it's possible that it's too small, and then you should stop the program. In particular, that will eliminate cases where n is much greater than square root of x, because then the answer should be 0. Because this sum, even the biggest possible sum you can get, will not work. Otherwise, so if n is very small, this sum is okay, and you will see how much this is above the required threshold. Let's say the difference of the sums is 20. So from this sequence you can drop down by at most 20. And what does it mean to drop down? You can decrease some value. For example, you can decrease this by 20 down to 78, but automatically the previous elements also need to be decreased by 20. Maybe additionally you decrease both of those by 7. So this gets decreased by additional 7, this by additional 7. Always you decrease a prefix by some amount so that you would still satisfy the increasing thing. So you can, for example, decrease 2 values by 7 or 3 values by 20. For every I from 1 to n, what you can do is decrease the sum by some multiple of I. And the sum, you have some limit for what the total sum is. It's up to x. You do it for every I up to n, which is square root of x. And that's some kind of dp. You start with dp of 0 is 1, and then you investigate dp of sum, it's, or dp, let's say, of t, it's so far, like after considering I values, some I values, of this number of ways to drop by t compared with max possible sum. And this t is limited by, in our case, 96. Generally, it is limited by around x minus n minus 1. Okay, we don't know the maximum in advance, by the way, but we should do this without knowing the maximum, and once we know the sum, we will know what maximum is possible. So how much leeway we have. And I think that's it. For each of n indices, we will iterate from 0 to x. Well, hard problem, but a nice one. Well, I don't like the statement. It was very difficult to understand, and the problem is obviously difficult to solve. So yeah, I'm not surprised by this decrease. So like 20 times less people solve this, because, well, this is solvable and this is just a hard problem. Okay, there should be Codeforces round starting in 30 seconds. Good luck with that. Today or tomorrow I will announce my group classes starting from next month. On Codeforces, €100 per month, €50 per month if you only want recordings and the access. And good luck. Contest has started. Oh, maybe there's a delay. No, the contest has not started. Still, good luck. See you. Good luck in the contest.